Hello everyone, this is Mohammad Usman, and today I'm going to explain you about the ICP3, which is NLP, Natural Language Processing, and I'm going to talk about the data cleanup process, and the second part is to split the data, and the third part is to train that data and make some prediction. So the step one is you need to import libraries like Panda and some natural language toolkit. And from natural language toolkit, you need to import sentence tokenization and word tokenize. So we will use this to function later in this program. Okay. So first thing is to get the data from this link. This is Twitter tweets data, which shows the tweets and their sentiment in the form of one and zero. So one is denotes the razor sexes, label. I mean negative remarks, and the zero denotes the tweet is not racist. Okay. First thing I notice in this data set is I have an unnecessary column that is ID, and I don't want this column. So what I did, I just dropped that column using this function, and the index is 0. So at 0 position, I have ID column. I just drop it. And this is my new data frame, which is named as new df. And as you can see that we don't have any id column in this new data frame. Okay, next step is to convert this column into the text form, so it will be easy for us to process this data. So this is a function we use to convert our data frame into the text format. And you can see the class is string, and you can also see that this is all the text data. After this, we tokenize the sentences. So this is a step-by-step process. You first need to tokenize the sentence, then you need to tokenize the word. So after the first I tokenize the text, and as you can see that the sentence is tokenized, like they are just in a continuous format. They are not in a line by line format. After that, you need to tokenize the word from the text. So as you can see the result, every word is tokenization, mean like extracting each word from the sentence. But here we can see that we have some special characters, and we don't want that in our data. So this is a frequency distribution of the words, so like which word appears at how many times. Like hashtag is appears 60 times. Okay, moving forward, we just plot this words into the graph, so you can as quickly see that okay, this hashtag is 60 times and this at the rate is 20 times appears. So it is a quick visualization of your data. Okay, so this is the what I need to remove the punctuation from this. So this function is alpha, so it will check the word is alphabet or not. So it will return true or false. It will return true if the word is without alphabet. So it will append this word um, into the word in this empty list. Okay, after that we did the same thing. We just show the frequency distribution, and after that I just use it like this is the frequency distribution, like user appears 18 times, d appears 13 times, and we just plot as the same way as we did before. After this, we don't want stop words. They have no meaningful any data. I mean, we cannot do much as these words, so we need to remove these. So for this, we use the built-in stop words function from the words we get before. Okay, after that, After that, we just store those words in a clean word, like which don't have the stop words. Like for example, from here we have is for, so we gonna remove that and store in the clean words. So after that, after running this function, we got the clean word like user, father, dysfunctional. So all of these are clean words. That's all we want. And the same way, we just print the most common use based on their frequency. There's a frequency distributed function, built-in function in NLP toolkit. After that, we just plot that as the same way, like the user appears 18 times and love appears just about 3 times. Okay, so this is a word cloud, and we are going to map all the words from our data, like from here, from this one, into the tutor image, and we are masking that word on the tutor logo. So on the tutor logo, yeah, so we are using this images. So we are converting into the NumPy array, and these are the libraries NumPy, and this is a word cloud. We are using image color generator. So after getting this image, we are going to render our words on this image. So as you can see the output, this marks function is using, if I remove this mark, so the words will be distributed all over this black window. And we don't want that. We want our words to be fit on the tutor logo. So user appears most of the more times. So that's why the size of this word based on their frequency. The higher the frequency, the bigger the word. Okay, so we are doing stemming. Stemming is just like you are removing the prefixes, just like flying. We are converting flying into fly. So these stemming function do this is the built-in function stem, and we are using stemming on our the clean word. So as you can see that, like there will be sunshine, there will be e. It removes the e from this word. Going down. So this is another snowball stemmer. We have two types of stemmer. This is another function. The output is nearly same between those. Between the okay. This is the limitizer. This is we are just getting the root words of the what you say, the root words of the word. Just like for example, converting cats into cat. So we are getting the root word. Okay, so there was a positivity, so it convert positivity into positive. So it's a root word of positivity. Okay, going down, this lematizer works same as the stemmer, so but it gives us a good, a correct, I mean better output than the stemmer. After that, we have a post POS tagging. So part of C tagging, so it will what it will do, it will tag each word with the uh, with the uh, with the words. Like for example, user is noun, and we have I have give the list here. Okay, okay, like the JJ mean adjective, JR mean adjective or comparative, NNS means noun plural, or RVR mean adverb. So it giving me the part of speech of each word here. The adjective or any comparative word. Okay, okay, going down. Now it's time to split the data, and we need to make some prediction. For that, we need to clean our sentences. We cannot do or our on the words. We need a whole sentence. So I'm going to take only 1,000 tweets from my data frame. The reason is why I'm getting 1,000 tweets. The tweets are more than 3,000 because of the RAM size. I have a less RAM size here. So if I try to compute over 3,000 tweets, So my system will be crashed because I don't have any more RAM or powerful engine. The reason that's why I'm getting 1,000 tweets. Okay, I'm converting these tweets to the list, so it will be easy for me to clean them. So this function str lower, it will clean all the tweets, and this function lambda, it will uh, it will clean all the special character from my tweets. So you can see that uh, the user when the father dysfunctional, and you can see that there's the @ sign, there are some hashtags, so it removes all the special characters from my tweets. After removing it, we need to remove the stop word, just like we did before in our words, in our token words. We are doing here same with the sentences. So should have, yourself, these are the stop word, and we remove them. You can see the user, father, dysfunctional, selfish, drag. So they don't have any stop word. Okay. So after that, I just tab POS tagging, like part of speech tagging to my word in my dispute. Like the user will be tagged with the noun, father will be with adverb. Okay, so these are just tagging each word with my part of speech. After that, I need to convert my raw document into the matrix form of TF-DIF features. So this TF-DIF is extract the feature from the sentence. So here I'm using sklearn library, and from sklearn library I'm importing TF-DIF vectorization. So I am just extracting the feature of my sentence. So either here I'm using the tweets list, and I'm just passing it here, and I am just transferring or I mean converting this sentences into the vectorization form. And and I'm just using this vector as a vocabulary. Like here, I'm just printing the words from all the tweets, and this is the features, sorry, the vocabulary is in here, so it's just showing the user is appeared this time, father appeared this time, and there's the and this function returning me the all the vocabulary in my tweets. And this is the matrix form or the array form of my sentence. So it will be easy for me to train the data or to split the data from sklearn. I'm going to split the test and train data. So this is the function xtrain, xtest, ytrain, ytest. So this is the function basically which I import from the sklearn model. And here I'm just splitting my data. So the 70% training and 30% test. And here I'm just importing support vector machine from the sklearn, and I'm going to fit my data. This is the xtrain data, this is the ytrain data. So after fitting that, I can predict my data using this CLF predict function. So I'm predicting on my test data because it is my test data is 30%. So it will compare my test data with the my train data. And here the y is the label. The label is the y is the label. Label is the sentiment, the 1 and 0 which I showed you before. And okay, after predicting that, this is the response. We can see the response of our prediction. And after prediction, we need to calculate the accuracy, how accurate our model. My model is 91% accurate because I just used 1,000 tweets. If I use 3,000 tweets, so my data will be more accurate. Because of this RAM size, I just use some of the tweets. So my accuracy is 91%. So this is all about my ICP3. If you have any question, any concern, please feel free to ask me. You can comment on my YouTube video, so I will be able to reply it. Thank you so much.